I'm going to prove this is possible.
And places it in such a way that it forms a triangle-like structure. Then he takes another one and places it in between the two sticks. So once he removes the brick, we can see the matches lifting this
is fake.
No, it isn't. This is why you do math instead of trusting your intuition. I first found the half angle between the two bottom sections of the rope is 24 degrees. Then at vertical forces on the bottom point is the mass of the bricks times gravity going downwards. I'll be generous and assume it's 18 pounds or 8 kilograms, which is 78.6 newtons. Plus the tension in this section of the rope times the cosine of 24 degrees plus the same thing on the other side. This means the lower section tension is weight divided by 2 times the cosine of 24 degrees or 43 newtons. Then at horizontal forces, there's just tension times the sine of 24 for the left section minus the same thing on the right, which is 0. For this point on the left and vertical, we have the upper tension times the sine of beta, which is 60 degrees, minus the lower tension times the cosine of 24 degrees equals 0. Meaning the upper tension is the lower tension times the cosine of 24 divided by the sine of 60 or 45 newtons. By doing some more of this simple math for the horizontal axis, we can calculate the net force on the matchstick to be the weight of the bricks divided by 2 times the cotangent of 60 degrees plus the tangent of 24, which is 40 newtons. This structure can fail because either this match is crushed or because of Euler buckling. The dimensions of the match are 2 by 2 by 45 millimeters, which means we can calculate the max Euler buckling force to be 51 newtons and the max crushing force to be 100 newtons, which both are bigger than the calculated 40. And then finally at the top point, the horizontal forces cancel out, and then vertical is the combined force from the shelf and match minus 2 times the upper tension times the sine of 60 degrees. That means the weight is on the top match, and as we know, stress is weight divided by the contact area of the rope, which is about 4 millimeters times the width of the match, which was 2 millimeters or 9.8 megapascals, which is fine for this type of wood. But the force is all in equilibrium and no match is breaking. That means this structure has tensional integrity or tensegrity.